So let us start with example of alkane, alkene and alkyne. Means more the double bond. If single bond, what is the meaning of pure single bond? Pure single bond means no resonance. The bond length is directly proportional to single bond character. This lone pair and this lone pair, what is the difference? This lone pair is delocalized. This pi bond and this pi bond. First of all, we will check resonance. This is not resonance stabilized and this is resonance stabilized. Hello to everyone and welcome to my channel. In GOC topic, we are already studying the general organic chemistry. The today's concept and today's lecture is based on the bond length. Today's we will learn how to compare bond length. We will focus only on bond length, how to compare different atoms bond length. So let us start with example of alkane, alkene and alkyne. ABC represent bond length. Bond length means BL. In short, I will write BL means bond length. So this is alkane, this is alkene and this is alkyne. The order of bond length is A greater than B greater than C. Now we have to explain why A is greater than B and A greater than C. A has single bond and B has double bond. Means more the double bond. If single bond replaced by double bond, this means there is a bond strength increases. Bond strength increases means bond length decreases. Similarly, if double bond replaced by triple bond, more stronger will be the bond, less will be the bond length. In short, we can say that more single bond character, more will be the bond length. If there is a double bond, stronger bond, less bond length. Triple bond, more stronger bond, less bond length. So we have to check the single bond character. Got it? Now let us take one more basic example. In this example, we have to compare bond length of carbon chlorine. This is also carbon chlorine. This is chlorocyclohexane and this is chlorobenzene. Now we have to compare carbon chlorine bond length. What is our approach? We should check single bond character. In this there is no resonance. Absence of resonance, and we can say that it is a pure single bond. What is the meaning of pure single bond? Pure single bond means no resonance. This lone pair is undergoing resonance. Now due to resonance there is a double bond character. Double bond character means strong bond, and strong bond means less bond length. Got it? So what you have to do, you have to check single bond and double bond character. Now this has single bond character, this has double bond character, therefore bond length of A is greater than B. Got it? More single bond character, more is the bond length. Now, what is the conclusion of this concept? The conclusion of this concept, this is to be note in your notebook. The bond length is directly proportional to single bond character. More the single bond character, more will be the bond length. More the double bond character, less will be the bond length. Got it? More the single bond character, more is the bond length. Now, let me take one more example. If we have to compare bond length of carbon-carbon in benzene and carbon-carbon in cyclohexane. While comparing the bond length, do not go for the complete stability of the molecule. We have to check only single bond, double bond character. We don't have to check the entire stability. Got it? Now in this case, since we have to compare bond length, this has double bond character, let us replace A by B, and this has single bond character. In this case, B is greater than A. This is the order of bond length. Why B is greater than A? Because B has single bond character, A has double bond character. Got it? You have to focus only on single bond and double bond character while comparing bond length. Let us suppose I ask you, what is your marks in chemistry? Then you have to told me that this is the marks in chemistry. You don't have to told me this is the whole PCM marks. The complete total of PCM marks is different and the chemistry marks are different. Similarly, if I ask you to compare bond length, then what is your approach? You should check only single bond and double bond character. Got it? So write down these two examples. First of all, in your notes, write down A and B. and write down this concept. Now let us try some examples. You have to try some examples, then I will answer. Some example based on bond length only. In this example, what you have to do? You have to compare bond length. Which bond length you have to compare? The indicated alphabets. You have to compare these bond lengths. Got it? Write down the example. Write your answer in your notebook. Then I will discuss the answer and explanations. Pause the video and write all the examples. Pause the video and write all these examples. You have to watch further videos only after attempting the all questions. Got it? You have to attempt all the questions and then you have to watch further video. And it is recommended to attempt on the paper notebook, or it is recommended to write on your iPad, or you have to try, solve. Now, what is the answer for first? We have to compare bond length, and we know that bond length is directly proportional to single bond character. This lone pair and this lone pair, what is the difference? This lone pair is delocalized. Delocalized means there is a double bond character. This means bond length will be less. This is localized, only single bond character, more bond length. So more double bond character, more stronger bond, less is bond length. Now in second example, this is completely no conjugation. In this example, this is a conjugation. Now after conjugation, there is a single bond character. Got it? How many RS has single bond character? One RS has single bond character. While in C, first you have to draw resonating structure and you have to check single bond and double bond character. Again, this pi bond will undergo resonance. Got it? Now, while undergoing resonance, this has single bond character, single bond character. How many RS has single bond character? 2 RS has single bond character. In this, 1 RS has single bond character, no RS has single bond character. This means bond length is C is greater than B is greater than A. Got it? You simply have to check single bond, double bond character. So only 1 RS has single bond character. In this case, 1 and 2 RS has single bond character. More single bond character, more is bond length. Now in third example, this is pure double bond, means it is not delocalized. While in benzene, there will be a single bond character. 1 RS has single bond character and 1 RS has double bond character. This means A is greater than B because of more single bond character. Now in fourth, this pi bond and this pi bond. First of all, we will check resonance. This is not resonance stabilized and this is resonance stabilized. Now due to resonance, the indicated bond has single bond character. Got it? So more single bond character, more will be the bond length. So first of all, you have to check resonance. Because of resonance, single bond character, more bond length. Got it? Now try this. Now in example 5th, this has 2 equivalent RS. A equal to B, because this has two equivalent RS, two RS of equal stability. This means bond length will be equal. While in sixth, this ester is resonance stabilized. Got it? Now due to resonance, A has, this has single bond character, while it has double bond character. Now which RS is more stable? This is more stable RS because it is a neutral. This is unstable RS. Means which will contribute more in hybrid, first will contribute in more in hybrid. This is stable RS, this is unstable. More stable because neutral is more stable than charge. Got it? Now since it is more stable, this means contribution in hybrid is more. This means A has more single bond character. B has less single bond character, because this contributing resonating structure is unstable. Therefore, A is greater than B, bond length. Why A bond length is greater than B? Because the contributing single bond character of A is more stable RS. Now in seventh, it is single bond, double bond and triple bond. So single bond greater than, double bond greater than, triple bond. Now example 8th. So this is most commonly question which is asked in my class. Majority of students ask this question. So what is, first of all, what is the answer of bond length? Among A and B, which is resonance stabilized? There is no resonance in A and B. Then what should be our approach? We will go for hyperconjugation. Now, how many alpha hydrogen in A? In A, we have 12 alpha H. B, we have 3 alpha H. Now, out of 12 alpha H, when we draw hyperconjugating structure, this is the hyperconjugating structure. During hyperconjugation, there is a single bond character. If I remove one alpha H, there is a one hyperconjugating structure as single bond character. How many hyperconjugating structure as single bond character? 12 hyperconjugating structure as single bond character. Why 12? Because of 12 alpha H. Similarly, if I undergo hyperconjugation, 3 hyperconjugating structure has single bond character. So which has more bond length? The first is greater than second. Means A is greater than B. Got it? While comparing the bond length, as I explained earlier in my class, that while comparing the bond length, you should focus only on the particular bond length. You don't go for the stability of complete molecule. Complete molecule stability is different concept, and particular bond length, bond strength is different concept. Since we have to compare the bond length, therefore we will focus on this bond only. How many hyperconjugating has single bond character? 12. How many hyperconjugating structure has single bond character? 3. This means more bond length of A. Got it? What is the answer of 9th? More RS has double bond character. One RS has double bond character. No double bond character. C is greater than B is greater than A. Why C is highest? Because of only single bond character. While B, we can say that only one RS has double bond character. In A, we can say that when we undergo resonance, there will be negative, negative, negative. In all this RS, this carbon chlorine has double bond character. So for simplicity, I will write 3 RS has double bond character. Got it? What about 10th? Which is resonance stabilized? This is resonance stabilized. This is also resonance stabilized. But the difference is, this resonating structure has single bond character. In this RS also has single bond character, but negative on oxygen is more stable. And in this negative on carbon is unstable. So if it is more stable, this means more contributing structure comparison to this. What is your answer? There is a double bond character. There is also a double bond character, but negative on oxygen, negative on carbon. This is more stable, means more double bond character. More double bond character means less bond length. Got it? You simply draw RS. This RS is unstable, carbon, negative charge consists of carbon. This R is stable because negative charge on oxygen. More stable, more contribution. What about 11th? Now in 11th, this lone pair undergo resonance. There will be a double bond character. If I draw a resonating structure, there will be negative, then negative will be in carbon, negative in this carbon, negative on oxygen. While how many RS has double bond character? This 1, 2, 3, 4. We can say 4 RS has double bond character. While in B, the negative will be this ortho, para, ortho. How many RS has double bond character? 3 RS has double bond character. Got it? This means we can say that bond length of B is greater than A, because more double bond character, less bond length. Bond length is inversely proportional to double bond character. And what about 12th? A equal to B equal to C, because all RS of equal stability. What about 13? A equal to B. What about 14? We have to compare A and B. This means first of all, we have to draw resonating structures. This is the one of the RS of naphthalene. This is the second RS of naphthalene. And this is the third RS of naphthalene. Now, we have to check A. This is our A, this is our A, and this is our A. How many double bond character in A? In A, 2 RS has double bond character. Now, we have to check B. This is our B, double bond, single bond, single bond. In B, 1 RS has double bond character. This means more double bond character, less bond length. Then what is the answer? B is greater than A. Got it? You have to simply draw resonating structure, and if there is no resonance, go for hyperconjugation, and then you have to check how many single bond, double bond character are in different resonating structures. Got it? So that's all for today's lecture. And apart from this lecture, there is one announcement is there. I started a teachers training program, faculty training program. Those teachers who are those who are studying in the college and they want to be a teacher in coaching or school, this program is for them. And apart from this, those who are teaching in the school and they want to upgrade their knowledge so that they can teach in IIT JEE and NEET, this faculty program, training program, FTP program is also for there. And apart from there, those who are teaching, already teaching in NEET and JEE, and they want to upgrade their organic chemistry knowledge, they can join this. So this is the complete course for faculty training program. The main focus is on the improvement of the subject knowledge and how to effectively teach the IIT JEE, NEET and other aspirant for organic chemistry. If you want to join this course, then just call on the number given, or you can write in the comment section. I will share the number and you can call them for further process. And those who are watching, please tell me from where you are watching. Mainly I am teaching these lectures for the South Indian students, and if you feel it is good for you, then definitely I will keep teaching and continue my lectures. And please spread the word, please tell other friends also. All these lectures are free in the YouTube. So you can enjoy organic chemistry for IIT JEE and NEET free on YouTube on my channel. Thank you. Jai Hind.